All right, welcome back to Cloud Computing and Big Data, Lecture 8, Infrastructure as a Service. We learned actually in the first part of the lecture that we were using all over the course already in a way or another infrastructure as a service. Whether that's really end user facing, like our EC2 images that we basically try to get with the AMI image, for instance, for deep learning, or that we maybe use MapReduce, but inherently underneath was, of course, the infrastructure EC2 again providing the computing. So in a way, infrastructure as a service is also always needed. The question is it visible to you, or do you just see platform as a service? Is there something like an IDE that you use for software engineering, or if you play or can create something with some form of platform, underneath you will find the infrastructure enabling it. We will have the platform as a service and software as a service in subsequent lectures where we much more go into real applications that you may know. But of course, think about that applications of IAAS are platforms, or those which are basically almost like platforms like MapReduce, for instance. But let us now go a little bit more into IAAS. Also think about the conceptual aspects again, how I actually deploy them. And of course, being in Iceland is an opportunity which is almost unique in the world to be for infrastructure as a service. And so let's review that together with a small video here, which captures really some good properties, why Iceland is just a very good location also to put your infrastructure here. So the video shows you there's a specific version of an NVIDIA solution that is offered by the Verne Global Data Center. As I said, usually we go there. We did this 2 years ago, but of course now because of COVID, we don't. You see, of course, that Iceland is quite nicely connected to, and basically both worlds, the US and also to Europe. There's not a problem of energy here, especially when you think about geothermal energy, which is quite there, but also hydropower, of course. There are interesting contracts with power. We have sustainability in terms of contributing to renewable powers and green energy, as it is called, right? So 100% free cooling. You learned in one of the lectures that cooling is the largest problem we have basically in a data center, apart from the, of course, true cost. And then you have seen, which is also maybe quite remarkable, that Iceland is, despite of the earthquake that we experienced in one of the lectures, also one of the most safest spots on Earth, which also takes, of course, different measurements inside, like political ones, war, and other likelihoods. So I think it's a quite interesting space to create data centers. And you see you have them with Verne Global. This is one example. We also have been with some classes and had some collaboration also with Advania in the past. They have, of course, also systems here, the Advania Tor, for instance, and also provide then different service offerings. While now the one from Verne Global you have seen here is now very specific, a partnership with NVIDIA to say they have a very interesting hardware for being ready for machine and deep learning at scale on an enterprise level. This is something what they sell and what they, of course, internationally can sell. It's not bound to Iceland. So, everything with an IP address can talk to the services here. But when you go there, then you really have sometimes cages even within the data center around some clusters, which are really extremely protected. You have man traps, that prevent everyone to just enter this data center. So speaking of that, the infrastructure is really advanced and of course offers a lot of opportunities just by the location here, because it's very cold compared to many other countries. And also you have the interesting green energy aspect if you think about, that the Green Deal and all of other factors we have here in Europe. So, but this is just one example, and there are more and more common. This is, of course, something where everyone tries to have a unique selling proposition. Advania is really much focusing on the IAAS cluster level, pushing really the idea of HPC flow, but also bringing more AI workloads into the game. So we don't review all of them for fairness, because we had Verne Global now as video. I put the Advania video at the end of the course, so you can basically see here in the course hours or so the video of Advania. Of course, you can think about as an infrastructure provider, it looks pretty similar. They have racks, they are located in Iceland, and of course there's the same benefits more or less from the location wise that of course also Verne Global has. So this is really an interesting movement also when you think about that in the past nobody really thought about this data center so much. When think 30 years back, 20 years back, that was in large cities. When you think about Finland, for instance, we had now the Lumi supercomputer last week, a press conference around it. This is a joint endeavor of 10 countries contributing to a pre-exascale supercomputer. And of course, in the former times, you would think that is, of course, Finland. That means it must be to Helsinki, right? In a data center there, because there is also where the owner, so to speak, or the driver that is basically hosting these solutions is sitting. It's the CSC, Center for Science, led by Kim Okowski. But where do they put it? They put it in Kajaani, much more north, while they still operated from Helsinki. And this is, of course, a movement we see in general. So movement to, let's say, more the Nordic countries, because basically of many of these benefits that we have in these countries. But let us come also a little bit back to Amazon. Again, basically seeing a little bit that we have here now really infrastructure as a service on many different aspects, right? While Verne is really pushing the AI and NVIDIA, Advania is pushing the HPC flow, and Amazon has just a massive broad portfolio. And with this, I wanted to show you how much options you even have in clouds when it comes to storage of data, which is also an infrastructure concern, way basically lower than any of the Amazon SageMakers or even the AMI image we discussed. Here it's really just about files, bytes, and bits, so to speak. However, of course, think about today, this is much more in terabytes. So let's look a little bit into this S3 storage, which is interesting. It is claimed by Amazon on a 99.999999 without end almost percentage of durability. So they really say this storage is impossible to lose, right? Of course, they can do this because they have lots of Amazon data centers. They have replication schemes, which is quite nice. But of course, you also noticed it's quite scalable, right? That's what we had also in earlier basically lectures already. So you can, when you need more storage, you just add it to it. When you have your own one, a physical one, of course, you have to buy more storage physically. And then the problem you have with this usually is it's actually not used for a long time, because you buy, let's say, a big terabyte disk and you're just adding up a couple of gigabytes or so per month. So in a way, it's always storage which is not used. And of course, here with the Amazon idea of just pay for what you use, what we discussed in the first part, pay by use, you have, of course, then the aspect that it's really extensible, or you can shrink it again if it's not needed anymore. And in business, that's incredibly often relevant. So you would have sometimes peaks, like for instance, Christmas or Easter shopping elements when it's about shopping. You have specific events, basically when you have maybe a Nordic Lights website, which does some rendering or some sharing of photos, as we discussed in the beginning. Then you basically have a high peak when the Nordic Lights are there, and probably in summer is not much happening around here in Iceland. So that means you need a service that is suddenly scalable to, let's say, many tourists that maybe want to share their data, and then suddenly in summer you have almost no users or something like this. So this is just one example where this is going through. And then think about that with the S3 interface, you have something which is now almost a de facto standard. It is a bit wrong to call it a standard because it's one specific vendor that defines it. So we should not say it's a standard, but people refer to it as a de facto standard. So you would find lots of other cloud vendors or applications. They offer an S3 interface to migrate easily with these APIs that you have either via REST interfaces or via the SOAP interface, somehow basically to make a migration of data possible. And then you can have different different types of storage. This is something what we didn't really discuss so much. We started in the course a little bit already talking about this object storage, and we were using it with one of our word count examples, if you remember a little bit. So this is just really like a bucket, something which is quite nice for your MP3s, for your music files, for images, for, let's say, all the non or unstructured data, as we call it, right? You just put it in, some videos, you have a little bit of a metadata and say who is allowed to see it, but there's nothing really needed as sort of a file, which basically is then thinking about really high latency, as low latency, or something like a database access all the time. So clearly there's a market for another service that of course also Amazon provides. And that is basically then the elastic block storage we come to in a moment. Before I give you some very clear, simple, I think, example of really how Amazon really can also go into many, many different markets just with these simple services. S3, when you do it with machine learning, which is, let's say, cutting edge in terms of using the cloud for deep learning and so on, for machine learning, you can also have the, let's say, normal people that are not related to machine learning at all, a complete different business segment served by just hosting a website. And of course, the same applies. You need storage. Maybe, again, if you have your photo sharing website, which is charged or gives revenues for those that upload, then basically what you need is a little bit of short cloud front from Amazon, and of course the domain name you have to buy and can actually do this via Amazon. And then you can have a very flexible Amazon S3 storage behind it that grows with the users or basically shrinks again, like now probably in COVID times, we see also less tourists. That would be probably also less used. But this is an interesting idea when you think how powerful Amazon can be. It goes quickly in so many different markets. When you think again about the portfolio now, this is one of the reasons why that works so well, because you can stick an S3 service which is used for this also for something completely different. And why? Because usually you would see that infrastructure as a service, yet being simple on the lowest layer, is of course a complete general purpose. You can have storage for this application or that application, doesn't matter. But often it is, of course, that it is relevant for many, many different applications, while the more you climb up in the stack, the software as a service or platform as a service is already extremely tuned for a specific purpose, right? So ERP systems, enterprise resource planning, right? These are SAAS services, software as a services. They are just for that. You cannot just simply create a website out of this. Or you have, let's say, customer relationship management services like Zoho. With this, you don't suddenly build a website. Of course, the storage, and this is the idea of this, let's say, more or less Lego concept, if you want, right? Which are a little bit there on the top right, illustrated. They have different Lego blocks. You just pull them different together and then have a complete new idea and or market actually catered or business domain covered. And so people would talk in the times when Amazon got more stronger that Amazon is quite disruptive in that, right? It had disruptive service models, but nobody thought about that this would be possible. Based, of course, on things you already learned in one of our earlier lectures, meaning economics of scale, which plays a huge role here. And of course, also the movement that technology in a way gets cheaper, but labor not, right? So administrators, automation, this of all are different factors, and of course, left alone virtualization, which was a key enabler in all of this. But you see a good example why infrastructure as a service is quite powerful even for such simple ideas like a website. Of course, behind that, you could see a smart idea, right? Now, firstly, once I'd chosen Amazon, I have my data there. So think about our website of sharing data. So now lots of data is growing over, let's say, 5 years. You have the website, more and more people upload. It's actually growing and growing, accumulating data. And now it is, so to speak, in a vendor lock. It's inside this cloud, right? It is not completely true because S3 offers, of course, interfaces to get the data out again. But of course, this costs. We will reveal that later. And Also, the idea is, of course, when you reach certain points that you have to think about long-term archiving. So you would deploy maybe an Amazon Glacier. We come to that also in a moment, so an archive solution. And of course, you will extend your website with a new functionality, maybe some automatic tagging of the location. So you would use an Amazon deep learning service with it that basically can automatically, by the uploaded picture, already, let's say, give an estimate on the location in Iceland. So this is things like, of course, their business model, that the Lego pieces are so nicely adjusted that every service almost works with any other service. This is, of course, half true when you go to the very top services like SaaS services. They use lots of services underneath. There, of course, sometimes it ends at SaaS service using also other SaaS service when they're for a different purpose. But the idea of infrastructure as a service and platform of a service combined is really, really powerful, particularly if you think about that this is a side business of Amazon, right? Think about Amazon is about shopping. So this is a brilliant idea, what was growing, and we see now the market dominance of Amazon. Of course, Microsoft and Google are not to be forgotten, but still, I think Amazon is quite an important player in this. But it's important, that's why we did Microsoft in the beginning and also the Google Collaboratory, and we will come to Google more, that see there are lots of different cloud providers, and basically you would have then Advania for specific solutions. The HPC flow, we look more in the spring when we look in the high performance course behind it. So these are all different elements where people try to get a unique selling proposition with their services. But if you're really honest, you find very, very similar services in the next cloud provider next door. And we see more and more cloud providers coming up and basically partly reusing those which are available in the public, or have a certain interesting product they basically roll out over the cloud, have a very nice security feature, for instance, where automatic data is, let's say, prepared for sensitive businesses like patient data, or let's say the new automobiles which are created in the cars. That's a design that usually the car manufacturers don't want to push open. So there are lots of interesting specific cloud vendors that come along. We will also look at UberCloud, which is also a very interesting one, which is bound to HPC and scientific computing a bit, and things like that. So interesting also in other areas because, you think about from website hosting, we jump to a complete different topic and still use the same service because it's very standard. However, you have to pay the price for it. And of course, this accumulates now if you think about that you have to combine all of this. So let's review this, what it really means if you have an S3 standard storage price. Of course, there are various variations on it. You see the first 50 terabytes per month, that's these kind of values doesn't look very much, but it's of course per gigabyte. Right? And this is something to think about, that 50 terabytes is quite a lot. And for huge enterprises that want to go the cloud way and that have a lot of data, this will multiply, right? And this is, of course, something to think that it's a per month charge here. It's not a one-time cost that you would have otherwise when you maybe buy the hardware itself. Then you see there's pricing schemes and really tables around. I just had here put some specific one to make specific points in the lecture. But if you go to the pricing models on Amazon, you find lots of different ideas how to save money, but also different stages and surprises. What, for instance, I think for many is when I talk about cloud computing, right, that are not really experts about this, people are astonished that once I put my data there, they can understand that this costs, but that an API call with, a put, post, delete, whatever, that these also cost, right? So the interaction with the data, the transfer in, the transfer out costs. You see here on the left, down there, the pricing scheme for so-called representational state transfer, API calls, right? For those that are not so much in REST APIs, I put here a graphic on the right-hand side. If you want to nail it down, it's a very HTTP interface based on HTTP to basically do something, not necessarily with data, could be also other services behind. But if you think about what you want to do with data, you want to actually update it, you want to post it maybe, or you want to get it, and sometimes you want to delete it. So it's kind of pulls down very general aspects of data. But once you do this, you see per 1,000 requests, you have a little bit of money. But now think about, even if it's only 1,000 requests here, you would say that's really irrelevant to talk about it. Think about how often the API is used when you have a game. How often is data from the landscape when you move around in an app used with an API call to get the new enemy or the new friend, whatever it is, in the picture? This is data that needs to be getting, and then you post your status, your interaction. So you use the API incredible often in many of the devices today, because the general idea is to go more and more to large cloud services and a very thin client. Of course, our phones getting more stronger. We can compute here and there more and store more, of course. But still, the general idea is, of course, to use the most power that is in the cloud. And with this, you have to interact all the time. And if you now multiply this by the number of users, and thinking about what we will soon reveal in the next lecture with Angry Birds, starting from a couple of users and beta testing up to productions in millions of users. When you then relied on this infrastructure, you want to have it, of course, not only that it really works well, but you got to make sure that you also get this money back from your customers of the game. So to derive, let's say, and this is one part of this infrastructure as a service, really, when you are a company, one part of your revenues, you always have to directly not put into your winnings, you put it back into your infrastructure. You have to save for it, so to speak, because, of course, your services are based on it. And of course, there are different models. Again, you see here on the top right now, the Glacier model. If you're a company, it sometimes makes not really sense maybe to keep everything so actively stored. So for many old, let's say, backups, archives, data that you don't really need right now in the second, there are different options available where it's then really cheap in the cloud. And where basically you should really consider then maybe doing it, because the benefit that you there also have is, of course, a kind of replication schemes and so forth. However, there's one big drawback when we talk about this. If you really want to access it, it's not usually just accessible, right? We see here, it can be restored within 12 hours. So make sure that, things you put deep in the glacier, as the name suggests, that is data that you perhaps not need really when a customer is just sitting in front of your face. Right, so this is really the main message I wanted to leave on the table. So storage is nice, sometimes cheap, but there are lots of other things around it that cost. And of course, adding up, when you now think about it's only storage, we also have to compute something. And the computing maybe also use some cutting edge GPU. So suddenly, all the pricing scheme makes sense. And that's why Amazon and other cloud providers make, of course, good money out of it. Now, when we think about the Amazon Elastic block storage, thinking also about what we just had, this kind of bucket store, right? We said it's good for MP3s, for music, images, everything with unstructured data. What about structured data? If I know I have a very good database and that is structured and I need very good I/O performance with this database, and most notably it should be consistently. So low latency connections, this is something like like this elastic block storage here, where you really have then essentially a hard disk you plug in, but in the cloud, right? And this is, of course, as the name suggests, elastic. So scalable up and down. And this is quite nice. And of course, mostly when you think about the pricing scheme, you just pay, so to speak, what you use in terms of this hard drive. Now think about it. I think you can roughly get up to 17 terabytes of elastic block storage. And then, when you buy this in hardware and not use, it would be also terrible. But of course, in the cloud, that's different. So you can go incrementally on this. As you see there with a pricing scheme, you have basically per gigabyte month. You see this EOPS month. This is specific SSDs, so to speak, that are specific provisioned, and also have different cost schemes. But in the end, there are different service models that you can use. And also, of course, we would say service level agreements behind it, and so forth. So this is an interesting, another segment of the infrastructure, right? We talked about this block storage where you really have, or the object storage, where you don't think about essentially the kind of structure in the data. And now we have a block storage where structured data, it's very beautiful for this, for databases and so forth, and a complete different segment. Think about an Oracle database using block storage, and it's many used in many different other cloud services as well. So what's a bit missing is, of course, now the file system approach, right? Of course, you put also on the elastic block storage that we have seen a file system, but in the object storage, there was a file system not really any more relevant. It was more bucket store, or as we've seen in the Glacier, something you really want to put away. Then in the block storage, we have really, let's say, a systematic approach like databases, as I said. But now the files, when you have individual files, there is even an interesting approach from Amazon, which I found good to note here, because they also had done some research on this to make actually this service happen. And the more users you have, of course, as a cloud provider, which is today, of course, one of the unique selling propositions, again, they can learn from their customers. They can learn what many people have used or want to use and can make analysis. And the interesting thing I found, that's why I put this service also in, is that they looked at that basically their customers is, when it comes to files, that only 20% of the files are used, right? And 80% happens to us all, perhaps. We don't really use often. So it's extremely infrequently used. Of course, if you know that, then you can do some interesting pricing schemes. You can prepare the infrastructure for that as well. And with this, of course, have a complete different sort of approach to a file, meaning that you basically only, again, can bill what's really used. And of course, still have all the benefits of replication and basically be ready for some data loss. And of course, think about also that this storage is then there in the cloud and can be used from different devices. So you could basically, services, sorry, from EC2 services, which are just plain having an AMI image, showing that deep learning does something on your data. But of course, you want to do it also with the Amazon Hadoop, right? Where we discussed, okay, this Elastic Hadoop service, Elastic MapReduce really, that wants to also have access to data. So it works with different types of data infrastructures together. And this is, of course, also a beautiful aspect here. So usually, again, you would combine all of these different ones together in some form or another for different purposes, as we just have now reviewed. And when you then carve out and learn from user experience like they did here, for instance, this is, of course, quite interesting that the more powerful and the more users you have, the better you can grow, the better fine-tuned services you can provide. And of course, your infrastructure provisioning will be better and better. Oops. So another aspect I talked to, and we will look more into other applications than on the PAAS and really on the SAAS level, right, where the right interesting applications take place. It's still interesting to see that on the infrastructure as a service level, there's still lots of applications that are not directly from Amazon or not directly using services from Amazon. And of course, that's why it works so well. And the good examples I bring also in the beginning of the course, just here shortly again. Again, Airbnb, we said they use basically this Elastic MapReduce service, but they also use 200 Amazon EC2 instance, for instance, for one application to analyze it. So they need the infrastructure. They need the sort of infrastructure as a platform in a way with the MapReduce. We have seen Spotify, which has quite, let's say, some million of songs available with Amazon S3. Right? And this is, of course, think about how many users Spotify has. They all have to get in some form the music. And of course, this means they interact with the service, and the interaction of the service also costs. So they have to put it in their business model when charging for Spotify, that they also have to pay Amazon for their infrastructure. Right? That's why, for instance, Spotify is not completely free. It's like $9.99 per month or so. So it's also not expensive. But of course, this goes with, again, the idea of having many users and so on that can then help them to cover the infrastructure costs. And if you go on in the AWS marketplace, if you may be here working for a startup or in a company in Iceland being seriously considering this, there are lots of other good examples in the AWS marketplace. where people had already sort of different problems. You have seen there's lots of MapReduce instances there that you can use. Some of them are particularly well tuned and for different purposes. So there's also, let's say, added value in these services. I encourage you to look into it. We've spent not much time on the AWS Marketplace because we also want to explore other cloud solutions in the course and not get just bound by that. But it's an interesting idea that, of course, what you do now is you open a platform as a marketplace really for interaction with other people. So you say you open up other third-party vendors that contribute to your own product to create an added value other product, and they sell it via you, so to speak, over the AWS Marketplace. And you find lots of different interesting products there, from really plain operating systems up to interesting data products or machine learning ideas. So maybe just have a look if you want, and then you see much more examples than just Airbnb and Spotify that are, of course, very prominent examples, I think, especially also here in Iceland, thinking about Airbnb and tourists and so forth. So another good example how IAAS is differently used is basically the car manufacturer Volkswagen Group. This is basically now a complete different segment. It's manufacturing, a complete business domain. But of course, they have to think about, do I really want to go to public cloud providers, right? Always. Or do I not think about something we called this hybrid cloud, if you remember, right? So the hybrid cloud was something when we were using private clouds and public clouds together. That could mean that there's some certain elements that are, for instance, from the data perspective, not so sensitive. I could do in Amazon. I do AC2, I do maybe in deep learning, time series analysis about it and learn something about my customers, and it's not so sensitive. Another aspect is when I have this related to some, let's say, aspects which are maybe directly linked to the car model, where the car model should be never basically coming out before the car is really manufactured. That's one of the most kept secrets usually of companies in the car and, automobile industry really, to protect your designs and your ideas there. Then you're hesitant of going to the public cloud, right? Then you suddenly think about there should be some form of a private cloud. Means that someone on site needs really to create essentially a cloud, because you cannot just ask Amazon, please buy me or create me a cloud in-house and then get all the benefits that AWS usually has. Of course, that wouldn't work. So for that, we have a specific lecture also, which is based on OpenStack. OpenStack and the other derivatives, very similar products which enable you to create your own cloud environments. And then you have something which is, of course, still using virtualization privately in your, let's say, data center. But every now and then it connects out to a public cloud to do some business. And in this case, of course, it's important to be basically also interoperable with this, something we will also look in lecture 13 then much more in detail. Now, when you think about NetApp, that is another interesting example of this, because they're here a little bit specialized on easy migration from different clouds, right? So you can these interfaces I just was alluding to really, have that in mind by partnering up with different public cloud vendors, getting certifications, but also then pushing their data service to be built on top of other IaaS cloud partners. So in a way, this enables another market, as we have seen in the marketplace, right? So that you basically now can rely on these infrastructures, but you don't want to be perhaps as a customer directly bound by one of these big players and maybe want to get involved with NetApp, which has then, let's say, can jungle with different services on different levels. So it's something which is, of course, also more and more growing these days. Particularly in the light of the fact that they also have here and there their unique services. Here, for instance, the NetApp Cloud Data Services are, for instance, known, but could be any other provider that has something specific to offer. However, we see the model that you basically nowadays also want to be involved with different cloud service providers that provide you infrastructure underneath. Now thinking about the discussion when we said where is platform starting and where is platform ending, and how that is related with, do I do bare metal or rather clouds which are completely virtualized? You would say, when we pick this precise example, MapReduce, that you all know from our lecture, and Hadoop as an example, could be Spark, of course. It doesn't matter really, but the point is here to think about what deployment options you have when you think about this. When we have an infrastructure, what you could do is on-premise and totally do it customize as you like because you're in charge. You can make it as a MapReduce appliance. So you basically download some ready-made appliance. You can just use your virtualization scheme in your own company, and then you basically have a really nice model which is semi-virtualized already, or you do a MapReduce hosting. You cross the boundaries of the organization, so to speak, and offer hosting or taking hosting, right? This is now a little bit from the perspective as an infrastructure provider. What could you do with MapReduce as an example? And then you could have, of course, a fully cutting-edge solution, which is more or less MapReduce as a service, so just software putting out completely in the cloud. So let's move through this a little bit, what that means on the different layers and how we can understand that. But of course, this is not bound to MapReduce. You can do this now with Spark, with others. It's just give you an idea that, of course, as infrastructure provider, you have different ways how you basically can deploy the software and then making a scheme out of services for it. So this matters really for different criteria, really. So you would have different price performance ratios. With I/O operations. We have the data privacy concern. I said about private clouds working together with public cloud. That could play a role here. Data gravity. We said about accumulating lots of pictures from tourists about Nordic lights. So data enrichment. Do I do something new with this, new insights of the data, putting deep learning on it? Or MapReduce, letting people to work on the data. And of course, then productivity of data scientists or less, depends. Basically, when the clouds are already in production, just to be used, a ready-made solution, for instance. So these are all criteria where you think about where the deployment model decisions needs to be done. Either it's in your company or if you are an infrastructure provider. But of course, if you as a company need these resources to compute, maybe some deep learning scheme to understand your customers, you automatically get into that role. You being now an infrastructure provider. The question is, do you do it on your own, on premise, full custom, or you move gradually to the cloud? But we now see in this different deployment models. So you have basically the purchase of a complete commodity cluster on your own. I think that's pretty clear. You have the total cost of ownership on this. And of course, you have a lot of staff that really has to deal with it, install Hadoop, and does everything around it. However, you could also think about, yeah, my administrators just need to know a little bit about virtualization technology because we're smart enough. Somewhere in the cloud, like in the AWS marketplace, there are MapReduce appliances or somewhere else which are already curated, which are quite nice. So maybe I just have this now downloaded and it works with my pre-installed configured version of Hadoop and our Hadoop distributed file system. And then of course can do the same with Spark on another basically virtual cluster that I configured. So basically I just need to know a little bit about virtualization and I'm done, right? So this is of course helping already to do lots of things. When you then talk about MapReduce hosting, deployment is basically a thinking that we host MapReduce for you. So you have already kind of a bridge between the organizational boundaries, right? You basically have the idea of an internet service provider in the end. That this is something where just MapReduce can be hosted for you and you take advantage of it. You don't need to know anymore anything about this to really, employ virtualization, which is already very close to what we already discussed here in MS Azure, right? You remember we had this deployment script that we edited, and you can also deploy, and some have done this in the assignment. They changed, for instance, a number of workers because 2 was a bit too much, maybe 1 is enough. Of course, in production, you have something like 20 or 30 workers, and maybe that is what you want to change. So in a way, you have still the possibility to adapt and automate how your infrastructure looks like, right? So this is something which you can configure and you can do different things there. While when you use just, let's say, a complete MapReduce hosting deployment, which is already running as a, so to speak, ready-to-run service with a pay-per-use model, you have less options. Essentially, you just send MapReduce jobs and that's it, right? So because the rest is already taken care of. It's of course for people that don't know anything about these technologies and just want to use it for the computing power and the algorithms, a very valid option, right? You have a swipe the credit card thing and can use a Spark or Hadoop cluster, and you have to know not really anything about it. Indirectly, you maybe use MapReduce jobs, and even for that are different clients. You have seen, for instance, all the Hadoop ecosystem around it. So let's say the MLlib machine learning library on top. So if you know machine learning, it will basically inherently have MapReduces it sends to Hadoop, but you are just working on machine learning. So these are different models and admittedly a bit here tuned to MapReduce, but basically can be done with any other software like Spark, for instance. No, and we have actually already see a service like this with the Elastic MapReduce service, right? We have tried it ourselves. We had a practical lecture on it, so you know how it works. We did word count, for instance. We didn't have to set up anything. It was just basically provided on an EC2, automatically installed Hadoop, so to speak. Everything was ready. The same with Spark and all the other Apache ecosystem. So this is, of course, a very nice idea of a service. And I think that's all what I also wanted to tell you today. It's of course not a practical lecture. You have seen it, some conceptual aspects we rather review today. And many of those things we already had in earlier versions of the course because we had put the practical elements really first in the course. And we review it now step by step other ideas in the concepts. So this is for the fairness to the Icelandic cloud providers here, not a video about Verne. But this is now about the Advania data center. It is also an interesting video, shows you the relevance in the Nordics and also the connections. So please have a look at this. And we basically are done with lecture 8 today. Remember, we are not done completely today. We will come back here to our quiz and then basically also to the Q&A session. So we break here for, let's say, 5 more minutes and talk to you then.